One of the things that I want to talk about today is there's two types of quantities that we're going to talk about. One type of quantity is a quantity that you're very familiar with already. It's called a scalar quantity. Back when you were first learning math, back in first grade, kindergarten, all you dealt with was scalar type quantities. You talked and you learned about, this basket has 4 eggs in it and this basket has 3 eggs in it. How many eggs in total do you have? And you said, well, 4 plus 3, and you counted them and you said 7. 7, that type of math is called scalar math. That type of quantity is called a scalar quantity because all it has is magnitude. 7 just represents a magnitude. Now, we were talking the other day how in statics, one of the big things that we want to learn about is how forces act and react on bodies. And we even talked about, back in chapter 1, how we looked at units and units of force and how units of force in U.S. units might be pounds or kips. All right? Well, a force is a quantity as well, too. But it is different than what you were used to back in first grade. Because a force has a magnitude, but it also has a direction. Okay? It's not good enough when we're talking about forces or when we're trying to add forces together or manipulate forces. It's not good enough to only talk about the magnitude of the force. If I'm trying to design a beam and I say, oh, the beam has to carry 1,000 pounds, what do you, or what would you tell me is missing in that statement? Well, which way is the 1,000 pounds acting? Up, down, right, left, at some angle. You got to know that. So it's not good enough to just say 1,000 pounds. You got to say 1,000 pounds acting in such and such direction. Okay? Along with the direction, you probably also want to know the point of application. If you have a beam and the beam's 10 feet long, there's going to be a difference in how that beam behaves if that 1,000 pounds is acting down and it's right in the middle of the beam, or it's 1,000 pounds acting down and it's 2 foot away from the right support. So again, we deal in the statics portion of the class, we deal with forces a lot. And forces are a different type of quantity than you're used to, at least back when you were young. Now, you should be used to vector quantities, though, okay? Because you've had them already. I mean, even if you've not taken physics yet, you still have had vector quantities. You know those drafting classes you took? Well, you might never have thought about it, but when you were doing the little wall section, you were drawing the footing, and then you were drawing the wall, you're drawing all those lines, and you had them scaled out. I mean, those lines that you're putting the pencil on the paper, or the line on the computer screen, those are vectors. They are a certain distance long based on some scale, and they're going in a certain direction. I guarantee you, your teacher, if you're trying to draw a foundation wall detail, and it says, based on this scale, the foundation wall is 8 foot high, and you say, okay, 8 foot, and you drew it this way instead of vertical, I don't think you're going to get a real good grade on that detail. So there was a certain rhyme or reason to that wall detail, and it was really based on vectors. Now, you didn't think about it like that. I'll tell you the other place that you came into vectors, I know, was surveying. your intro to surveying class. I mean, you're drawing those little traverses or those boundaries, those, whatever you're drawing. That's all vectors, you had a bearing, and the bearing was north 15 degrees east, and the bearing was 202.89 feet. Well, does that have a magnitude, a length? Yeah. Does it have a direction? Yeah. Does it have a point of application? Yeah, because you had to start someplace. You had to start at the pin in this corner, or the rock out in the middle of the road, or whatever. So you didn't think about it like that, but you've already become aware of how vectors are used. So anyway, that's